Hello. We've been working so far on inequalities in this chapter, and all of the inequalities so far have only had one variable, mostly solving for x. And when we get that answer and we're ready to graph it, we graph it on a plain number line. Today, we're going to introduce inequalities with two variables, both x and y. And as you guys know, when we have an x and y in an equation, it actually is a line. And so we're going to basically learn how to find inequalities that are a line, and we're going to graph them on a coordinate grid, and we're going to be shading portions of that coordinate grid depending on what our inequalities and what our variables are. So that's what we're going to be working on today in our notes. So let's go ahead and jump right on in. So like I said, we're working on inequalities with two variables, and that's x and y. Okay, so we're going to go ahead and take a look at an equation. Let's go ahead and have y plus 4 is less than 3x. And we're going to go ahead and look at the steps on how to solve and then graph this equation. So step number 1 is we are going to put it in the form of a line, y equals mx plus b in slope-intercept form. Now, remember that our m is our slope and our b is our y-intercept, because we're going to be graphing these. So remember, m is our slope, which is how steep our line is, and that is our rise over run from one good point to another. And our b is our y-intercept, where our line crosses the y-axis. Okay, so we're going to go ahead and put that in that form. And what that basically means is we're going to go ahead and isolate y, and then we're going to make sure our plain number is after our x. So in order to do that for this problem, I'm simply going to subtract 4 from both sides of our equation. That's going to cancel over here, and we now have y is less than 3x minus 4. And if I had an equal sign there, you know that we would be basically just a line format. But now our answer is not just the line. Our answer is going to be a whole portion of our graph. So step number 2 is to plot your b on the y-axis. Okay, so we're going to go ahead and take a look at our graph here. And we are going to plot our y-intercept, which in this case is -4. So we're going to go ahead and plot our dot on the y-intercept at -4. Okay. Step number 3 is to move your slope. Now, remember, your slope is rise over run. And if our rise is a positive number, we're going to go up. If it is a negative number, we're going to go down. If our denominator is a positive number, we're going to go to the right. If it's a negative number, we're going to go to the left. So in this case, we knew that our b was -4, and our slope is 3. However, when we have a slope that is an integer, we need to turn it into a fraction. And the way that we turn it into a fraction is we simply write it over 1, because we need 2 directions. So the 3 is positive, so that means we're going to go up 3 from our y-intercept, and our 1 is positive, so we're going to go 1 to the right. After we have those 2 movements, then it's time to go ahead and plot our next point. So from this point, I'm going to go up 3, 1, 2, 3, and 1 to the right. I'm going to continue doing this all the way to the end of my graph. Up 3, 1, 2, 3, 1 to the right. Up 3, 1, 2, 3, 1 to the right. Up 3, 1, 2, 3, 1 to the right. And then I'm off the graph, but I want to go the other direction as well. Now, in order to go the other direction, I'm going to do the opposite of both directions. So I'm going to go down 3 and 1 to the left. So down 3, 1, 2, 3, and 1 to the left. Down 3, 1, 2, 3, and 1 to the left. So you can easily see if that's going to continue the line that you've made or if you've made an error. Okay, step number 4 is to draw your line. Now, at this point, we have to focus on the inequality of our equation. If our inequality is a greater than or a less than, then we're going to draw a dashed line because anything on that line is not a part of the solution. It would make the inequality false. However, if it is a greater than equal to or less than equal to, we're going to make a solid line. So in this specific equation, we take a look and I see it's a less than. Less than tells me I'm going to make a dashed line. Now remember, as we make this, we need to go ahead and make sure that it goes all the way from one side of the equation to the other. And in this case, it's going to be a dashed line. So I'm going to go ahead and make a dashed line through all of those points. Okay, and then I'm going to make sure I put an arrow at the end of both sides. Okay, so let's go ahead and move on to step number 5. So we're going to shade for step number 5. Now, if it is a greater than or greater than equal to, then I'm going to shade above the line. If it is a less than, then I'm going to shade below the line. And this is just your general idea of which you're going to do. And then we'll talk about how to prove that you did the right side mathematically. It's easier the flatter your line is to know which one's above and below. As it gets steeper, it's a little harder to pay attention and see that. So I kind of picture I have a weight on one side of my line and I weigh it down just a little bit where it would tip if I put a weight up top. And that tells me a little bit more, which is above and which is below. So this one is less than, so I'm going to shade below the line. Now I shade really lightly because later on in the chapter, we're going to go ahead and do systems of inequalities on the coordinate grid. And we're going to actually have some part that has multiple colors overlapping, which is why it's important that we're going to use our pencil instead of a marker or a pen, because like I said, we are going to be doing this with multiple lines and parabolas and lines and different items all on the same side. Okay, so that is our answer to the problem. That is our graph. Now, our last step here, number 6, is to make sure that we shaded the correct side. So number 6 is we are going to pick an ordered pair. We're going to pick an XY. Now, I always pick the same number whenever I'm doing this. And the place that I always pick is 0, 0. Now, if 0, 0 is on the line itself, then I have to pick a different one, and I generally try and use the 0.11. Why would I pick these? They're easy numbers to use. Now, once that I've picked those, I'm going to plug them in my inequality and see if it's true. I'm going to plug those numbers for X and Y in for my inequality, and I'm going to see if they're true. So my inequality, as you guys know, is y is less than 3x minus 4. So as you can see, 0, 0 is not on it. So I'm going to plug in a 0 for y and a 0 for x and then solve. 3 times 0 is 0. 0 minus 4 is negative 4. And so I have 0 is less than negative 4. Now, at this point, I'm going to ask the question, is this true? Okay. Now, if the answer is no, then I am going to shade the other side from the point 0, 0, or 1, 1 if I use that one. If the answer is yes, then I'm going to shade that side that contains the point 0, 0. So is 0 less than negative 4? Well, no, 0 is not less than negative 4. So that means the point 0, 0 should not be shaded. And that is what happened. So I did verify that. So this, ladies and gentlemen, is how to solve inequalities with two variables. We are going to put it in the form of a line, y equals mx plus b. We're then going to plot the y-intercept and move the slope, rise over run. We're then going to draw our line. If it is greater than or less than, it will be a dashed line. If it is greater than equal to or less than equal to, it will be a solid line. We then shade the portion of our graph that fits the equation. Less than is shaded above, less than is shaded below, and greater than is shaded above. We then clarify that by picking a point, either 0, 0, or 1, 1, and we verify that we've shaded the correct portion of the graph. Let's go ahead and get some practice on Desmos.